Okay, here's again a slightly more complex question, but you know, if you understand the pieces, it's not a very difficult question. We're given 2 points, P and Q, are points on the parabola. So I've labelled P and Q, I've drawn my parabola. Find the coordinates of the focus F and the equation of the directrix. Given that x squared equals 4y, well, we know that x squared equals 4ay. So if x squared equals 4ay, x squared equals 4 times 1 y. So a is 1. So straight away, the coordinates of the focus are here. The focus is 0, negative 1, sorry, 0, 1. And the directrix is this line going through 1. And we say y equals negative 1. Okay, easy. Right, so we're interpreting this information. I'm not going to do the whole working of this question. Show that the points P, F, and Q. Now, where's P? We go back down here. There's P, F, Q. So we're trying to prove that these things are collinear. Collinear means on the same line. How do you show things are on the same line? Well, first of all, we treat them as FP and FQ separately. If we can show that they have the same gradient between these two things, and if they have the same gradient, they're parallel, but if they share a common point, which is F, then they're on the same line. So you're going to show two gradients and explain that because they share the point F, they are collinear. Find the equations of the tangents to P at P and Q. Right. So you've got to find the equation. Tangent means derivative, okay, gradient. So working from x squared equals 4ay, and I'll work down the bottom here. X squared equals 4ay means y equals x squared on 4, and so y dash, which is the derivative, equals x on 2. Now there's the function, and you would say when x equals 4, you'll find that, and when x equals negative 1, which is the point P, you'll get the gradient. You'll get two different gradients. Okay, because of course the gradient here is going to be negative, it's going down. The gradient here is positive, it's going up. And you'll find the gradient, then use the gradient point formula to find the two tangents. So you've got a tangent there, you've got a tangent there. So let me just draw these things roughly. I'm only going to attempt these roughly. But you'll have a tangent, okay, work with me here, that does something like that. You'll have a tangent that does something like that. Now, I've drawn it that way because part 4 says show that these tangents intersect at right angles on D, where D is the directrix. So first of all, how do you do that? What is this point? You have to figure out. So if we found the two tangents, I've got an equation here, I've got an equation here. How do you find the point of contact? Point of intersection is simultaneous equations, and you should get an x coordinate of something but a y coordinate of negative 1, and that's proof that these two things intersect. Does it prove that they intersect at right angles? No. So again, once you find the gradient here and here, you'll find that they multiply to be negative 1, and again you have to show that working to support your conclusions. So just working through this question, you know, although again it's just a slightly different approach, none of this is difficult. Okay, it's easy to find focal length and then find directrix and focus. Collinear is a particular method I've described. Tangents is always got to do with your derivative function, and intersection, okay, simultaneous equations, and right angles is gradients. Okay, there's a solution for that.